In example 2, we're going to determine the rate law, and we're also going to calculate the value for the rate constant. All right, so I'm going to look at my data between these two reactants, and I see that trial 1 and trial 2, our first reactant is being held constant, while our second reactant is changing. So I'm going to deal with these numbers. So this is going to be for the I minus, because my S2O8 2 minus is being held constant. So I like to deal with the bigger numbers on top. So I'm going to do trial 1 over trial 2. So I have 0.034 over 0.017 raised to a power equals 2.2 times 10 to the negative 4 over 1.1 times 10 to the negative 4. So I end up with 2 to the x equals 2. So again, that's simple numbers. I know that x equals 1, but if it were not simple numbers, I could take the log of both sides, move the exponent down, and get x times the log of 2 equals the log of 2. Divide both sides by this log of 2, and I get x equals 1. So the order with respect to the I minus is first order. So if I do the S2O8 2 minus, I am going to identify the two trials that I need. So I see that the I minus is being held constant in trial 2 and trial 3, and my concentration of the first reactant is increasing. So I'm going to look at trial 3 over trial 2. So trial 3, 0.16 over 0.08 raised to the power. You always put a concentration factor raised to the exponent is equal to the rate factor. So trial 3 over trial 2, and I get 2 to the x equals 2. Again, x equals 1. This is also first order. Orders are generally only 0, first, second order, maybe a third order, but they don't get very high. All right, so if I wrote the rate law, I would get rate, R-A-T-E, equals lowercase k, square bracket of S2O8 2 minus times I minus. So formatting this correctly is very important. There's subscripts here, there's superscripts here, there's math noted here. Please make sure you include all these pieces. All right, now we need to calculate the rate constant. So I can go back and plug in data. I have rate, I have concentrations and orders. I can solve for K. So I'm just going to take trial 1. 2.2 times 10 to the negative 4 is my rate. It's equal to K raised to 0, or the 0.08, and I know that's first order, and the 0.034 was first order, and I do the math and solve. So it'd be 2.2 times 10 to the negative 4 divided by both concentrations, 0.08 and 0.034. And I get that K equals 0.08088. And the units on that would be, we have molar per second, we have molar and molar, so one of the molars cancels out. So it's inverse molar and inverse seconds.